After speaking about the salt in the water and the salinity, now let's talk about the gases which are dissolved in the seawater. And when we talk about the climate and climate change, this is actually the most important aspect of the oceans, how much of the gases, particularly carbon dioxide, can be absorbed by the oceans. So the gases in the ocean will move backwards and forwards. We have an exchange between the ocean and the atmosphere all the time. Gases are being released from the ocean into the atmosphere, but are also absorbed by the ocean. So there's an exchange which is happening all the time. And for a given temperature, pressure, and salinity, the water, the oceans, can only absorb a fixed amount of any gas, any particular gas. So we can't have an infinite amount of gases being absorbed by the ocean. A certain amount can be absorbed, and this is dependent on the temperature, pressure, and salinity. But the main real player here is the temperature. The temperature is the dominant control of how much carbon dioxide can be dissolved in the oceans. And because of this, it turns out that in cold water, we can actually dissolve a lot more gas, a lot more carbon dioxide than in warm water. As well as under high pressure, we can have more gas going into the oceans. But generally, the pressure at the surface of the ocean, the air pressure, doesn't change that much. So the pressure is not really a key player here, but really the temperature is. And again, in cold water, we can dissolve more gas. A common example is if you take your Coke or your beer, a warm beer will have less gas in it than a cold beer. So if you want to put gas into your beer or into your soda water, it's better to have cold water than have to warm water. The cold water will have to absorb a lot more carbon dioxide, so it'll be a lot fizzier than a warm drink. Same with the oceans. The ocean's warm waters will actually absorb less gases, and this is a problem when we're talking about global warming, because as the oceans get warmer, they can take up less carbon dioxide from the atmosphere. And the oceans are generally saturated. It means that they have the maximum concentration of certain gases, but they're not saturated yet for carbon dioxide and for oxygen. And the reason that they're not is because they basically are involved in the processes of photosynthesis that we'll talk about in a second. But if we look at how much percentage-wise of the gases in the atmosphere we have in the atmosphere compared with the oceans, we see something quite interesting in the oceans. If in the atmosphere we said we have about 78% of the air around us is nitrogen, N2, and about 21% is oxygen. Most of the air, 99% of the air in the room, is nitrogen and oxygen. In the oceans, dissolved gases in the oceans, we have about 48%, which is nitrogen. So in the atmosphere, percentage-wise, we have a lot more nitrogen than we have in the oceans. If we look at the oxygen, we have about 36% of the dissolved gas are oxygen, so more than we have in the atmosphere. But look what happens when we see carbon dioxide. The carbon dioxide, we have about 15% of the dissolved gas is carbon dioxide, compared with the atmosphere, which is 0.035. Now it's 0.041. It's increasing in the atmosphere. We have about 415 parts per million, which in percentage is 0.041. So there's much, much more carbon dioxide dissolved in the ocean water. And so we often say that the oceans act as a reservoir for carbon. They're actually kind of a bank where we can put lots of carbon in the ocean, keep it in the ocean. But as we just said, that if we change the temperature of the ocean, then we're going to change the amount of carbon dioxide that can be absorbed. On the right, we can actually see the concentration in seawater in parts per million by mass. And again, we can see we have a huge amount of carbon dioxide which is dissolved in the oceans. So if we talk about the dissolved gases in the oceans, the changes really are due to the levels of oxygen and carbon dioxide. And the amount of oxygen and carbon dioxide are mainly controlled by living beings, plants, animals in the ocean, which need oxygen and also carbon dioxide. So photosynthesis, for example, of plants, phytoplankton in the oceans, microscopic plants, algae, they produce oxygen, but they use carbon dioxide for photosynthesis. So when we have lots of biological activity in the oceans, we'll see a decrease in carbon dioxide and an increase in oxygen. But when the plants and the animals die, we have respiration, and we have the opposite happening. So this takes up oxygen from the water and releases carbon dioxide due to the process of respiration. So if we look at how the oxygen and the carbon dioxide vary as a function of depth, and we can see here on the right-hand side going down to 2 kilometers depth, far below where we have the light from the sun, we said the photic zone was only 100, 150 meters in the top part of the ocean. And that's what we need also for photosynthesis. So photosynthesis by plants occurs only in the photic zone, in the top of the ocean, because we need light for photosynthesis. And that causes high levels in oxygen, because the plants are giving off oxygen, and low levels in carbon dioxide. So in the top of the ocean, the first 100, 200 meters, we can see in the red curve has a minimum, because we basically are using up the carbon dioxide for photosynthesis, but we have a maximum in the oxygen, because, again, the photosynthesis produces oxygen. But as we go down below the photic zone, where we don't really have any sunlight, then we have the breakdown of organic matter, the respiration by the animals, by dead matter, by plants, which causes lower levels in the oxygen. It uses up the oxygen, and so we see the green curve is further to the left when we go down into the deep oceans, and higher levels of carbon dioxide, because the respiration gives off the carbon dioxide back. So we get these profiles where you can see oxygen is much higher close to the surface and drops quite dramatically when we go down into the depths of the ocean, and the carbon dioxide is very low at the surface but increases as we go down into the depths. Now, I mentioned again that warmer oceans will absorb less carbon dioxide. Here we can see an example for the water temperature on the x-axis and the solubility, how many grams of carbon dioxide we can have per kilogram of water. And again, we see that as the water gets warmer, we can have less inside the ocean. And so this is one of the big worries for climate change, that as the oceans get warmer, maybe the carbon dioxide, which is at the moment in the oceans, will actually be emitted from the oceans. And instead of the oceans taking up carbon dioxide and removing it from the atmosphere, maybe they'll become a source of carbon dioxide and emit it back into the atmosphere and could amplify global warming.